Normal curve, page 2. This is our last page of notes for the school year. Aren't you excited? Woohoo! Bells and whistles. All right, so these ones are a little tougher because we are solving for missing mean or standard deviation or even both. So these ones are a little bit trickier. We actually have to write and solve an equation, or on the second part of the example, we actually have to write and solve a set of simultaneous equations. All right, so for A, up until 2006, the mean height of basketball players, wow, I left out the word players, sorry, basketball players, was 79 inches. If 20% of them were shorter than 74 inches, find the standard deviation. All right, so here's the problem. We don't know the standard deviation. So normally we would just do inverse norm, but we don't know what to put here for the standard deviation. So what we have to do is just do that 0 and 1. Okay, so that's all we're going to do. So 20% below. So I'm going to go z equals inverse norm 0.2 for 20%, 0, 1. And that tells me that I have a z-score of negative 0.842. Anytime mean is 0, standard deviation is 1, that's a z-score. So now I'm going to use my formula, z equals x minus mu over sigma. Well, I just found out z is negative 0.842. In the problem, we were told that x is 74 and that mu is 79, and we're looking for sigma. So I'm going to subtract, so I get negative 0.842 equals negative 5 over sigma. Multiply by sigma, divide by negative 0.842, and sigma is 5.94. So that is our standard deviation. All right, and B. On a certain freeway, 10% of the cars travel faster than 75 miles per hour, and 12% of the cars travel slower than 65 miles per hour. What is the mean and standard deviation for the speed on this particular freeway? So this time we don't know mu or sigma. So I'm going to need two different z values. So I'm calling this one z1 when there's 10% above. So I have z1 equals inverse norm. And remember, inverse norm doesn't understand percent above, so I have to do percent below, 0.901. So I get a z-score of 1.28. And we are given the speed of 75 miles per hour. So 1.28 equals 75 minus mu over sigma. Then I'm going to do z2, and we were told 12% slower than 65. So here's my z-score, and slower, so 12% below. So z2 equals inverse norm, 0.1201. So I get a z-score of negative 1.17. So I'm going to write my equation, negative 1.17 equals 65 minus mu over sigma. And now I have a set of simultaneous equations to solve. So I'm going to multiply both sides of these by sigma. So I get 1.28 sigma equals 75 minus mu. And negative 1.17 sigma equals 65 minus mu. And now I'm going back to integrated 1 where I solve simultaneous equations. So I'm just going to subtract these two equations. So when I subtract here, minus a negative becomes plus a positive. So I get 2.45 sigma equals 75 minus 65 is 10. And again, minus a negative, so I have a negative mu minus a negative mu, so those cancel out. Divide both sides by 2.45, and sigma is 4.08. So we now know our standard deviation. So I'm going to go ahead and plug that into one of the equations to find mu. So I just plugged it in right here into this equation. So I got 1.28 times 4.08 equals 75 minus mu, and mu equals 80.22. So the mean is 80.22 miles per hour, and the standard deviation is 4.08 miles per hour. And that finishes up our notes. Hooray! We're almost done. Miss you guys.